Satellites detect serpentine iron jet stream at Earth's core. Scientists have discovered something big, thick, and as hot as the sun that's quickly coiling around the center of the Earth. European Space Agency satellites have detected a large jet stream of liquid iron flowing beneath Earth's surface at a quickening pace. The stream is moving westward beneath Canada and Russia at a pace of 30 miles per year. Lead researcher Phil Livermore explained the discovery as an accelerating band of molten iron circling the North Pole like the jet stream in the atmosphere. This molten jet stream might be caused by buoyant forces in the Earth's core, or variations in the magnetic field within the core. And no, before you ask, it's not Marijuana Man's fabled trouser snake. We know, we already checked. Keep watching for cool space stuff. NASA discovers Mercury is both shaking and shrinking. Mercury. It's the closest planet to the Sun and had long remained an enigma to researchers until just a few years ago. Mercury is the smallest planet in our solar system, and new research from NASA suggests it might be getting smaller, as the space agency found that the planet is warm, tectonically active, and shrinking. Prior to crashing on Mercury, NASA's Messenger spacecraft photographed the planet's surface for 18 months. It found long cliffs, called scarps, which suggest Mercury may experience seismic activity. The researchers expect the seismic activity on Mercury to be similar to Earth's moon. According to Space.com, the planet is still hot enough to keep contracting and have a molten outer core. That same core has helped sustain Mercury's magnetic field for billions of years. Perhaps the biggest takeaway from the research is that Mercury now joins Earth as the solar system's other tectonically active planet.
Earth-like planet discovered orbiting our closest star. Scientists have discovered a planet orbiting the star closest to our own Sun. If that's not remarkable enough, the planet lies in the star's so-called Goldilocks zone, meaning it's possible the planet's surface supports liquid water and perhaps even life. The exoplanet Proxima b is believed to have a rocky surface and its minimum mass is 1.3 times that of Earth. It orbits the red dwarf star Proxima Centauri within its habitable zone at a distance less than 5% the distance between the Sun and Mercury. A full orbit, meaning a planetary year, takes about 11 days. Proxima b is tidally locked, meaning one half of the planet is always bright and the other is always dark. The temperature of the planet's surface could be around minus 40 degrees Fahrenheit. If it has an atmosphere, the temperature could reach as high as 86 degrees Fahrenheit on its light side, meaning it could be warm enough to hold liquid water. The planet cannot be viewed by current telescopes. However, scientists are hoping new telescopes to be built in the next decade will reveal some of its secrets.
The Great American Eclipse is less than a year away. America has started counting down to a total solar eclipse that will be visible from coast to coast on August 21st next year, and NASA says it will only be visible in the USA. A total solar eclipse occurs when the new moon passes between the Sun and the Earth. In the path of the eclipse, the Sun and its rays are completely blocked by the moon. The last total solar eclipse visible from the US took place in 1991, but could only be seen from parts of Hawaii. The 2017 eclipse will start in Oregon and pass over 12 states before exiting in South Carolina. Its path will be 67 miles wide. The Great American Eclipse of 2017 will be the first total eclipse only visible in the US since the country was founded in 1776. Total solar eclipses occur about once every 18 months, but it's rare for them to be so accessible. According to NASA, next year's eclipse will be the first to stretch across the entire country since 1918. But if you missed this one, don't worry. NASA says the US will only have to wait until 2024 for another total solar eclipse.
Jupiter's iconic spot is turning up the heat. Mankind is beginning to unravel the mysteries of our solar system's biggest planet, starting with its atmosphere. Jupiter's atmosphere has roughly the same temperature as that of Earth, despite being 5 times farther away from the Sun. Dubbed the planet's energy crisis, this detail has long puzzled scientists until now. The explanation for the gas giant's superheated atmosphere lies in its Great Red Spot, which is a massive 10,000-mile-wide hurricane with 400-mile-per-hour winds that has been raging for centuries. Jupiter's atmospheric temperatures are around 1,700 degrees Fahrenheit, but the area directly above the Great Red Spot is hundreds of degrees hotter. This suggests a link between the planet's upper and lower atmospheres, despite being separated by a vertical distance of 500 miles. The heat is likely caused by high-energy acoustic waves shooting up from the storm. The waves cause atoms in the air to move around, raising the temperature. NASA expects to gather more information from the Juno spacecraft, which is now in orbit around Jupiter. Now that scientists have discovered why the atmosphere is so hot, maybe they can also figure out why the spot is red.
Life on Earth may have been sparked by super flares from the Sun. Some 4 billion years ago, only 70% of the Sun's energy was received by the Earth, not enough to warm the planet. Despite this, geological evidence shows it was a warm globe with liquid water. Scientists have long been puzzled by this paradox, but new research may finally have an explanation: superflares. Our Sun today produces superflares once every 100 years. The bulk of this energy is kept from reaching Earth by the planet's strong magnetic field. When the Sun was much younger, only a few million years old, the flares were much more frequent and intense. The Earth then also had a weaker magnetic field. Particles from solar storms collided with nitrogen molecules in the atmosphere, breaking them into individual atoms. These, in turn, split carbon dioxide molecules into carbon monoxide and oxygen. Nitrogen combined with oxygen to form nitrous oxide, a potent greenhouse gas that would have warmed the planet enough for liquid water to exist. Energy from the solar particles may have also helped create complex compounds like DNA and RNA, the building blocks of life. Researchers pieced together a timeline of the Sun's evolution by analyzing data from NASA's Kepler Space Telescope, which found stars resembling our Sun.